Now, fine. So far we have seen what all the introduction which are needed for scheduling algorithms. Now let's see one famous scheduling algorithm named as shortest job first scheduling algorithm. Okay, shortest job first scheduling algorithm. In order to understand this, first let's solve some examples. Okay, it will make it very easy. Let's first see some theory. Shortest job first scheduling algorithm. Among the arrived processes, process with the least burst time or execution time. See, burst time and execution time both mean one and the same, right? Will be given preference. It is a non-preemptive scheduling algorithm. You know what is meant by non-preemptive scheduling algorithm, right? Also, it is a priority-based algorithm. Okay, why it is a priority-based algorithm? It is a priority-based algorithm because the process with the shortest burst time will be given higher priority, right? Whereas the process with the longest burst time will be given lesser priority. So clearly it is a priority based scheduling algorithm. Okay. See, priority based scheduling algorithm has some disadvantages which we will see a bit later. But understand that why SJF is which shortest job for scheduling algorithm is also called as SJF. Okay. Why SJF is called as a priority? It is a priority based algorithm. Okay, understand it. This is because SJF is a priority based scheduling algorithm because the process with the shortest burst time will be given higher priority. Fine. Now let's see this example. See, once we see this example, this topic is quite simple. Okay, you'll be able to understand it. Now we have already seen in attributes of a process, we have seen what is meant by a process ID, right? A unique number which will be given to every process, which, okay, so process IDs are given 1, 2, 3, 4 and 5. See, all these are processes. Okay, this is one process, this is one process, this is one process and so on. They have given the arrival time of this process. Okay, 2 time units. Okay, the unit for this is time units. Anything, it can be either nanosecond or whatever, millisecond or whatever. And they have also given the burst time. Burst time is also called as execution time. Okay, you know that. Execution time. They have given this. They have asked find the average turnaround time. Okay, and waiting time. WT means waiting time. They have also asked something called as throughput, which we will see. Okay, we have not seen it till now. And they have also asked something called as schedule length. Okay, what is the length of the schedule? Now first let's see what is meant by average turnaround time. Average turnaround time of all the processes. See, every process will have a turnaround time. Why? See, we know that every process will have an arrival time to RAM, right? See, what is meant by turnaround time? Let us assume this is our CPU, this is our RAM, and this is our hard disk. Now, what is meant by turnaround time? Once a process has arrived to the RAM, we switch on the timer. Okay, the timer is initially at 0.00, whatever it is. Now we switch on the timer. Now, as long as the process is completed, once the process is completed, we will switch off the timer, right? In simple words, I can say that turnaround time is nothing but the time spent by a process inside the RAM. Okay, which means we have already seen that turnaround time equal to completion time minus arrival time. Okay, using this formula, we can calculate the turnaround time of every process. First process, second process, third process, and every process, right? Now we should have got the values. Now we need to find out the average. What is average? Add all the values which we have computed, which means all the turnaround times we have computed, and divide it by 5 because we have 5 processes. Okay, let's do it. Let's first let's first draw the Gantt chart. Okay, this is also called as Gantt chart. Fine. This is nothing but 0 time units. Okay, we are starting with 0 time units. Okay, we are starting with 0 time units. Now see, one more important point you need to note is our shortest job for scheduling algorithm will pick the process with the least burst time. That is fine, but it has to be considered that it can pick only processes which has arrived, right? In case if a process has not arrived to the RAM, then that process cannot be taken into consideration by the scheduling algorithm. Okay, that is very quite obvious, right? Fine. Now see this. Now we have started at time unit 0. Now has any process arrived at time unit 0? No process, right? The first process which arrived is P1, which arrived at time unit 2. So from 0 till 2, our CPU is idle. Okay, our CPU is idle means our CPU is not executing any process because no process has arrived to the RAM. Okay, see, only if a process has arrived to the RAM, our CPU can execute it, right? Now, since no process has arrived till this time, we can say that our CPU is idle. Now, what is the disadvantage of having CPU idle? By having the CPU idle, our efficiency will drop down, right? CPU efficiency will go down. As a result of which our computer will become a bit slower, right? But here we can't do anything because no process has come to the RAM. Okay, fine. Now let's see. Now at time unit 2, the only process which has arrived is process P1. Okay, see, it is a non-preemptive scheduling algorithm. Okay, have that point in mind. Our SJF is a non-preemptive scheduling algorithm. Fine. Now at time unit 2, only process P1 has arrived. Okay, see, I'm going to take this as P1. Okay, 1 as P1, 2 as P2, 3 as P3. Okay, process. Fine. Now let us assume process only one has come. Okay, so I'm starting with P1 at time unit 2, and its burst time or execution time is for 3 time units, right? Which means until 5, P1 will continue. See, we cannot preempt it within this time. Okay, those there might come a new process whose priority is greater than P1, but still we cannot preempt P1 here because it is a non-preemptive scheduling algorithm. Fine. Now let us assume P1 is done execution, right? Now at time unit 5, which are the processes which has arrived? P2 has arrived. Okay, P2 has arrived before 5 itself. Okay, it has arrived somewhere here. Okay, similarly P3 has arrived. P4 has not arrived because P4 arrives at time unit 6, but we have reached only till 5. Similarly, process P5 has not arrived. Okay, now among process P2 and P3, we need to pick the process with the highest priority. Now, which process has the highest priority? That really depends on which process has the shortest burst time, right? Now, among these two, the shortest burst time is process P2, which is having only 2 time units. So, we need to start with, see, as of now, we have completed P1, okay? Fine. Now, we are going to start with process P2. Process P2 will run till 7 time units, right? Now, at 7 time units, process P3 has already arrived, fine. Process P4 has also arrived, right? Both have arrived, but P5 has not arrived because it will be arriving only at time unit 8, but we have reached only till 7, fine. Now among P3 and P4, we need to pick the process with the having the highest priority. Now the process with the highest priority is nothing but the process with the least burst time. Now process P4 has least burst time comparing to process P3. So P4 will be scheduled by our scheduling algorithm and it will run for only one time unit. Okay, process P4 is also done. It will run till 8. Fine. Now at time unit 8, both P3 has arrived as well as P5 has also arrived, right? Now between P3 and P5, we might have to pick the process with the highest priority, and that is nothing but process P5 since it is having the least burst time comparing to P3. Fine. So P5 will run till time unit 10. Okay, so P5 is also done. Now we have only P3, so there is no other way. We might have to execute process P3 and it will run till 13 time unit. Okay, 13 time units. Fine. So we are done with the chart.